Educational robotics strengthens and supports student skills, developing their knowledge through creation, design, assembly, operation of the robot. Children and young students find it fun and engaging because they feel free to interact directly with both electrical and mechanical processes and procedure. In fact, the programming can be too difficult and boring when learned through traditional abstract methods. On the contrary, by having to control physical robots and see what goes wrong, students learn what robots can and can't do with immediate experience and understanding. So I decided to interview a high school sophomore so we can further discuss the particulars of a high school robotics team. I would like to give special thanks to upcoming junior Christopher Grace for participating in this interview. Due to the corona pandemic, we were unable to meet face to face, but we were able to conduct this interview via video recording. So, Chris, how long have you been a part of the robotics club and what sparked your interest in robotics?
So I started robotics in 8th grade as a programmer. I initially joined because I really liked the mechanical engineering side of the program. I've always been kind of hands-on. I did like Lego and stuff as a kid, so robotic kind of really suits my strengths.
When writing code, what are some of the particulars that you have to take into consideration?
So I do the programming for our team. My specialty is sensor-based programming, which is perfect for robotics because robotics programming is taking inputs from your driver, data from your motors and sensors, and using that to change what you're giving the robot command-wise. So what that looks like is a lot of feedback loops where you're looking at how something has changed in a given time interval and then acting upon that. So we use PID and odometry.
What are some issues that you had to overcome during competition?
That we go to, consistency is the number one thing that we need to nail down, that and reliability. The drive to a competition is probably the most rattling a robot is ever going to have in its lifespan. So you really have to look and make sure with a fine-tooth comb that everything on your robot is perfect and how it was when you left the building, because any variance will mess you up and you'll have to tune stuff on the fly, which is not good. Between matches, you need to look for stuff that usually gets loose. There's some stuff that lock tight and tight screwing just doesn't fix, so you have to be mindful of that. The robots collide into each other during matches, so as long as there's no broken parts, you should be able to go to the next match, but programming-wise, it's fairly the same. You might have to tune some constants on the field if you know that something is different between your practice field and the event field. But mostly it's just hardware stuff.
And can you describe to me what it's like participating in a robotics competition?
So the competitions that we go to every year are probably the funnest things that we do. They can be super fun and also super tense. You know you need to ascend to that next level and do well in your qualification matches. So there's some bickering that goes on between your teammates. But it's also super fun. When you win a match, you get super gassed up. Winning a competition is even better. That's super fun, getting awards and that stuff. It's great. And there's a social aspect as well. You're talking to these teams that you know and you work together with and you don't see a lot, which is another one of the benefits.
What are some technologies that can be created to increase robot performance?
So there's a lot of tricks that we've picked up on over the years, both hardware and software-wise, to make the robot better. Hardware-wise, it's we use a lot of low friction, low slop joints, and that keeps movement tight and precise. We use aluminum on everything to keep everything as light as possible. You don't want to be moving a heavy robot across the field at high speeds because it's not controllable and it's kind of a hazard. We build as little as possible, but it has to be, you can't cop out on structural support because there are impacts on the field. On the software side of things, we use a lot of feedback loops and control algorithms to make sure the robot is doing what it's supposed to be doing in the autonomous period. That includes PID, which is pretty much standard across the industry for robotics, and that's a way to make sure that your motors are precisely and accurately moving to their target. We also have a function that determines the position of the robot on the field using wheel rotations, which is something that we're really proud of, and it's done as well.
So tell me about Leesville Robotics team journey from the beginning of the season all the way into the cancellation of the World event.
So the high school club started in the 2018-2019 season. We started so late in the season that we didn't have any time to raise money or anything, so we just had to work with what we had in terms of parts. So that meant using steel and the inferior control system, which left us at a really big disadvantage. So we lost both regional events that we went to, got into states through a wild card, and then placed 20th or 30th, which was awful. But over the summer that year, we raised some funds through private donations, and we had a sponsorship, and we bought aluminum, a practice field, the new control system. We also just got generally better. So the first regional event we went to this year, we won, which takes you to the state competition, and we went to finals there, which qualifies us for the world event. Worlds is 720 of the top teams in the world, and they're from all these different countries. There's China, Japan, Italy. There's China, New Zealand, India. There's African countries and South American countries. It's really cool how you can all kind of get together in this one space and just be super competitive. Unfortunately, because of the coronavirus pandemic, the event got canceled, so we weren't able to attend, which is unfortunate. But we're working on stuff right now for the new season, and we're really optimistic for what the future has.
Now I'm going to show you what it looks like at an actual competition.
Yeah, what's it? Go time. Still ticking. Oh, look at this. The robot trying to stay up. You have 1 minute left in this match. Here we go. We're gonna get going. 2, 4, 6, 8, 9 here for Red Alliance. Look at that, that may be 10 cubes. Yes, sir. 2, 4, 6, 8. Yes, sir. It is 10 cubes.